call is now being recorded. So today we will discuss RC circuit and how we can solve the RC circuit and how we can find out the voltage as well as current transient. Okay, so we will deal in detail. So let me show you the RC circuit. RC, here R stands for the resistor and C stands for the capacitor. So it consists of a series of elements. That means R and C, they are connected in series. Resistor R and capacitor C, they are connected in series. RC circuit. This is generally referred to as an RC circuit. And across this RC circuit, you can see here a voltage. A voltage is applied across this RC circuit. Okay, a voltage is applied across this RC circuit. So here you can see a switch is there. Okay, so a DC source, a DC voltage V is applied across the series elements R and capacitor C. Okay, the current is flowing, as well as you can see a switch here. So the switch can either be open or it can be closed. Okay, so now we will see that suppose initially the switch is open. Suppose initially the switch is open. Here what happens? Initially the switch is open. That means this is an open circuit. This is an open circuit. There is no connection from here, this voltage source to here. Isn't it? So there is no, initially there will be no current. Initially there will be no current. So suppose what happens when the switch is closed? What happens? So this is a closed circuit. Okay, so what happens here? Here, the capacitor has an important property that it won't accept an instantaneous or sudden change of voltage. So capacitor will not accept a sudden change of voltage. So suppose at T is equal to 0. Okay, suppose at T is equal to 0, I am closing the switch. That means I am changing the switch to close position. I'm closing the switch. That means it is a sudden change. Okay, here a potential V is applied across this R and C. Suppose initially, before closing the switch, the initial voltage across the capacitor is 0. So before I am closing the switch, the initial voltage across the capacitor, let it be 0. There is no charge on the capacitor. Let it be 0 voltage across the capacitor. So when I am suddenly closing the switch, what happens? This voltage is applied across this circuit. Now what happens? Here the capacitor, it won't accept a sudden change in voltage. An instantaneous change or a sudden change, it won't accept. So this voltage won't be coming up across the capacitor. This voltage, because when we are closing the switch, as it won't accept a sudden change, the voltage across the capacitor will still be 0. The voltage across the capacitor will still be 0, even though we are suddenly applying a voltage. Instantaneously, the capacitor voltage cannot change. So it will still be 0 at T is equal to 0. So T is equal to 0. Time T equal to 0, the voltage across the capacitor will still be 0. So what happens here? But a current is flowing because this is a short circuit or a closed circuit. So current can flow through the resistor. Okay, so what is the current? Current I is equal. So this voltage we are applying here, the voltage we are applying here is directly applied across the resistor. Why? The entire voltage V is directly applied across the resistor because the capacitor voltage is 0. The capacitor voltage is 0. It won't accept a sudden change. Okay, so the entire voltage V will be coming across the resistor now. So what happens here? Here I, let I be the current. Let I be the current. So what is the current? I is equal to voltage divided by R. Because the entire voltage is applying across the resistor when the switch is closed. I am talking about time T equal to 0. Okay, so what is the initial current? The initial current I will be voltage divided by resistance, or V by R will be the current. Okay, as time passes, here what happens to the charge on the capacitor? Here the capacitor will slowly getting charged. The capacitor will slowly getting charged as time passes. So as the capacitor voltage increases gradually, the capacitor voltage will increase gradually only. Okay, and finally it will come to a constant voltage. The capacitor will get fully charged, and finally gradually it will come to a constant voltage. Okay, so what happens to the current here? Current through the circuit, gradually it will decrease. Why it is decreasing? Because as the capacitor charge increases, or the voltage across the capacitor is gradually increasing. Okay, so gradually it will increase, so it will place, so gradually it will increase. So this, the voltage applied here, the voltage applied here, that will be splitted into VR plus VC, isn't it though? So this V voltage will get splitted as VR, voltage across the resistor, plus the voltage across the capacitor. Okay, so the current will be slowly decreasing. The current will be slowly decreasing. So we need to analyze the current decreasing as well as the voltage increasing across the capacitor. So please remember that the voltage across the capacitor is slowly increasing. When we close the switch, it won't rise to a constant value fast. It won't accept a sudden change. So the capacitor voltage will increase slowly, gradually increase, and the current through this, the current through resistor and capacitor will be the same. Why? Because here the current, here this is a series circuit, this R and C elements are in series, the current will be same. The current will be gradually decreasing as the capacitor voltage here increases. Okay, now suppose the capacitor is fully charged. Fully charged means the capacitor potential becomes equal to the voltage here. The voltage we are applying, the capacitor entirely charges to that particular voltage. Here we are applying a DC voltage V. Okay, and the capacitor is getting fully charged to that V voltage. Now what happens? What happens to current? Here the potential across the capacitor will get equal to the potential here. So the two potential will become same. So what happens? The current will ultimately decrease, decrease, and decrease, and then go to zero, isn't it? So the voltage here there is a potential applied, and here the voltage across the capacitor will gradually become a constant value. So same potential across here and here. So since the two lines are having the same potential, one line, that the two ends which is having the same potential, what happens to the current? The current will become gradually decrease, decrease, and will become zero. So that is the voltage and current transient through an RC circuit. I hope this is clear.